All right, partial fractions. Now the problem with this topic is no matter when you're seeing it for the first time, some schools do it in Algebra 2, others do it in Precalc, others reserve it for calculus, but no matter when you're seeing it for the first time, the question is always, what the heck am I doing? A good student who can really memorize a cookbook series of steps and get through it will sort of be able to get through this without really having any idea what the heck's going on. But so just real quick, I want to explain what's going on. In this video, by the way, we will just get to the most basic ones where there's no repeated linear factors or quadratic factors where you have to start putting weird stuff upstairs. That's for video 2. This one's going to be just the basic process. So if you're already up to speed, you can skip ahead, but if you're curious what the heck's going on, this is it. In Algebra 2, they would have given you a problem like this and asked you to solve it or to, combine it. So they might have just given you this and said, simplify. And they would have expected you to figure out, oh, well, this has a common denominator of x times x minus 3. So you would do what it took to get everything together and get it to equal to this. So you would have said, hey, you know what? The common denominator for x and x minus 3, I just multiply them together. So that means that this guy needs to get multiplied by x minus 3 over x minus 3 in order to have the right denominator. And this guy has everything except the x. So I'm just going to put an x top and bottom on that puppy. Then when we combine them, we'll get 2x minus 6 over x times x minus 3 plus x over x times x minus 3. And then now they have the same denominator, we can just add them. So 2x plus x is 3x, then minus 6 over x times x minus 3. And at that point, you would circle this because that's your answer. You had successfully taken these two fractions they gave you and condensed them into one. You'll notice that this is this, just a factor version of that. Well, guess what? Partial fraction decomposition is where you're going to be given what would have been the answer in Algebra 2, and they want you to break it apart into several different fractions. Why are you doing this? Honestly, I don't know. It helps you integrate some stuff in calculus, but even that was a pointless exercise, in my opinion. Point is, you have to know how to do it. If you're watching this video, probably didn't come here by accident, it's probably on your test, so learn how to do it. But I just wanted to illustrate that what we're doing is we're taking something that was perfectly good in one piece, like this, and we're breaking it up into fractions, each of which is like part of the original. So the one we're going to end up with is going to have part of the denominator here and the other part down there. Let's get to it. All right, so I'm going to give you that same problem, and I'll see how we do the problem going forwards. So what you do is you walk up to the problem, and the first thing you do is factor the denominator. This factor is going to be x times x minus 3, as we just saw a second ago. So here's what happens. Since we have a common denominator here, this is going to be able to break up into two fractions. One is going to have a denominator of only x, and the other is going to have the other part of the denominator, x minus 3. If this had factored to three things times each other, like x and x minus 3 and x plus 4 or something, then we'd have three separate fractions. But we only have two. And then because each of these denominators only has an x in it, there's no x squareds, there's no squareds around any parentheses or anything, we're just going to slap an a and a b up there. A and b are just a couple of numbers. They're going to be integers that we're solving for. Well, hopefully integers. A lot of times there's fractions, but they're just the numbers we're solving for. By the end of this, we'll have a equals a number and b equals a number, so we'll end up with like 1 or 2 over x plus whatever over x minus 3. So here's the trick. At this point, we've got an equation that kind of looks like something we would have seen in Algebra 2. And we're just going to treat it like that. So if I want to take two numbers on the right and add them up to a single fraction, combine them, everything had to be over a common denominator, right? That was the rule. So this a over x, it's missing something. It's missing the x minus 3. So I got to multiply it top and bottom by x minus 3. And this b over x minus 3 is missing an x, because you notice common denominator has an x in it. So x there and x there. Now here's the trick. At this point, everything has a common denominator, right? So I'm just going to take the numerators and ignore the denominators. So all this becomes 3x minus 6 equaling a times x minus 3 plus bx. Now you might be thinking at this point, well, hey, how can we solve for a and b? Because we only have one equation, and that's two unknowns, and you always have to have two equations of two unknowns. I don't know why this works, but for some reason in this case, we're going to be able to group stuff fancy, and it'll work out. So we're just going to leave our 3x minus 6. We're not combining like terms. Everything that's on one side of equal sign stays there, and everything that's on the other side stays there, we're just going to distribute out the a, and we'll get ax minus 3a plus bx all equal to 3x minus 6. Now you might be tempted to combine x terms or something. Don't do it. What we're going to do is we're going to leave the left the way it is, but then we're going to group terms. So anything with an x in it we want to put together. So we're going to put ax plus bx sort of together in one little spot, and then we'll put our negative 3a out to the side. Last step is we're going to factor out an x from each of those terms. So it's like factoring by grouping at this point. We'll have x times a plus b when we factor out an x from those two terms. And then that minus 3a is just going to stay the way it is. Now here's the moment of truth, the moment of clarity, what's really kind of cool. If 3x minus 6 equals this times x minus 3a, the only terms on the right side that have x's in them is this puppy. And the only x's over here is that one. So that means that 3 must equal a plus b. Pretty crazy, right? And then the number on the left, there's a negative 6. And since these two things have x's in them, the only thing on the right that could possibly equal negative 6 is a negative 3a. So that means that negative 3a equals negative 6. Pretty crazy, right? That's a leap of faith. But at this point, we have two equations, two unknowns all of a sudden. So we got negative 3a equals negative 6. That means a equals 2. And I plug that into this equation. I get b equals, let's see, if a equals 2, b must equal 1. Pretty amazing, right? Now I'm not quite done. I just need to go and stick these back in my expression from over here, where I had a over x. So a over x, now I know a is 2, so I got 2 over x. And then b over x minus 3. And b I now know is 1. So these two things add up, and if I simplify, and you recall this is exactly what I had on that first page. So this, if I just combined them, would combine into this. Pretty crazy, right? So let's just remind you of the steps before we try another one. First we factor the denominator, so they'll give us something that's kind of got a mess downstairs. We've got to factor it. Then for each factor in the denominator, we're going to make a separate fraction, so we'll have a line with one factor under it, plus another line with another denominator. And we'll put a's, b's, and c's, one letter over each one. At that point, we're just going to treat it like an algebra 2 problem, get common denominators again, and set that all equal to the original. And then that last thing that's really tricky is we have to group all our x squared terms, our x terms, our number terms, and then get those equations to solve for a, b, and c. The only way to learn this is by practice, so let's take a crack. This is going to factor to 3x over x minus 1 and x minus 2. Now you notice I have two things multiplied together downstairs, so that's going to give me two fractions. I got an x minus 1 denominator one, and I got an x minus 2, and I just put these far apart because I know I'm thinking ahead I'm going to need to multiply something. So throw an a over one and a b over the other one. Alright, so now I'm ready to start combining stuff with common denominators. My common denominator is x minus 1, x minus 2, but this one right here only has an x minus 1, which means it needs an x minus 2. Of course, I can't do that to the denominator without doing that to the numerator. Now this guy has an x minus 2, but he needs an x minus 1. Alright, so I think I'm ready to go. At this point, I'm just going to set my numerators all equal to each other. So I will get the 3x equals a times x minus 2 plus b times x minus 1. Alright, now we start distributing stuff. Ax minus 2a plus bx minus b. Group my x terms together, it's next step, so 3x. So if I took this ax and bx, I'd get x times a plus b. And then my two other terms are going to be negative 2a minus b. Alright, so that means that because the coefficient of x on the left is 3, that means a plus b has to equal 3, since that's the coefficient of x on the right. And then there are no numbers on the left, which means that negative 2a minus b has to equal 0. So we have a system of two equations, two unknowns, nothing cancels. So I'm just going to write this other equation right below here, because I'm just going to add them together. So it looks like if I just add them, the b's will cancel, and I'll get that negative a equals 3. Therefore a equals negative 3, and plugging that into this one, I get that b therefore equals 6. right? Because negative 3 plus 6 would be 3. All right, so b equals 6, a equals 3. Last step, I just got to plug these in. Now remember, what I started with was just a over x minus 1. These were put in here for simplification work. So my answer is going to be a over x minus 1, so that's negative 3 over x minus 1, plus b, which is 6, over x minus 2. Pretty exciting stuff. We could check our answer by, yet again, multiplying all this stuff out. Sounds like a headache. I would encourage you to do it on the test if you have extra time, but of course that doesn't usually happen. All right, speed round. We're not actually going to fully plug and chug through the process. I just want to say, give you practice on how to spot what your breakdown should be. So I've got 3 things downstairs, which means I need 3 fractions. So one is x, one is x minus 1, and one is x plus 3. And then up top I just put an a. I just need 3 letters, and usually what a lot of books do is use capital letters. The books that are good use capital letters. The people who are crazy and want to confuse you use things like C1 and C2 and C3 because C stands for constant, and they have different ones. This is really bummer. Students hate subtitles or subtext, whatever. Those little numbers next to letters are really annoying. So at this point, we would just, if we were going to work this problem, we would just follow it through. This one has only an x, so it would need an x minus 1 and an x plus 3. This one is missing an x plus 3, and this one is missing an x and an x minus 1. You can see how nasty this is going to get. Not fun. And then this one, same story. Got 2 factors, x minus 1, x plus 2, a and b, and that one really is just like the ones we already worked. All right, I want to point this one out because there is one subtlety. You're only supposed to do this type of problem and do that whole a over one thing plus b over the other thing if the power upstairs is less than the power downstairs, the biggest powers I'm talking about. So this one is technically improper because we have this just as high an exponent upstairs as downstairs. If we had had 3x cubed over x squared, it'd be even worse. And what would happen is you'd do your partial fractions, and it wouldn't work out. You would get, I don't know what happens. There's either too many equations for the number of unknowns you have, or you'd have, more likely, you'd have an x squared on the left, and then you'd only have an x times a plus b or something on the right, and there's just no way to get, if the highest power on your right is x, and on the left you have x squared, you're hosed. And that's what will happen if we tried to work this problem. So the key is to notice that if you've got a high power upstairs and downstairs, the same power, or if the top was bigger, you have to long divide first. So we're going to take x squared minus 3x plus 2 and use polynomial long division, that into 3x squared. So x squared into 3x squared is just 3. 3 times all this is going to be 3x squared minus 9x plus 6. And of course I got my 0x, my plus 0, just make it look better. So when I subtract these cancel. I get minus a negative 9x, that's 9x, minus 6. All right, so that means that my answer is 3, and my remainder is 9x minus 6. So I'm going to rewrite this as 3 plus my remainder, 9x minus 6, over x squared minus 3x plus 2. At this point, we can do partial fractions, because you'll notice that upstairs now, I have an exponent of 1, and downstairs, I had an exponent of x squared. So it's going to work out this time. The key is to always remember that 3's got to be there. So let's do that. So 3 over 3 plus 9x minus 6 over x squared minus 3x plus 2. Now at this point, we can just ignore the 3, because it'll be on both sides. So what I would do is I would just figure, you know what, your answer is going to be 3 plus something. So factor the bottom, and we're going to get 3, so we'll just do the 9x minus 6. That's going to be x minus 1, x minus 2. Now we got, since we have 2 things in the denominator, we're going to have something plus something, x minus 1, x minus 2. So we got a and b. A is going to need an x minus 2. B is going to need an x minus 1. Alright, so we're going to get that 9x minus 6, which is the left side, equals ax minus 2a plus bx minus b. Apologize, we can't quite see that. So 9x minus 6 equals, so our x terms are x and then a plus b. And our leftovers are negative 2a minus b. So a plus b has to equal 9. And negative 2a minus b has to equal negative 6. If I add these two together, I get that, see the b's cancel, and I get a minus 2a is negative a, so a equals negative 3. Negative 3, so my final answer is a is negative 3, so I get negative 3, is that right? Negative a equals 3, yep. So negative 3 over its denominator, x minus 1, plus b. Now what is my b going to be? If a is negative 3, b equals 12. So 12 over x minus 2. So that's this guy, and all I did was just plug in my negative 12 for b. Positive 12, rather. Alright, so that's our answer. Because we did long division first, that's where that 3 came from. And then the other two were just the partial fraction decomposition of what was left, the remainder. When you get a remainder, you just plunk that over the original, and that's what that leftover is. If you don't remember long division, check out the long division review video I've got up, and there's probably a link to it right beside this video. Other than that, happy hunting. In the next video, we're going to do some cookbook stuff. We're going to see what happens when we have other types of factors, like if there's an x squared downstairs, or an x plus 2 quantity squared, junk like that. It's going to get a little juicier, so brace yourself.